All right, class, let's get started here. I think we stopped with the first or second one. So let's take a look at this one here. So the objectives for the day, I think, is going to be something that looks like this here. So simple equations with multiple angles, identities with multiple angles, and multiple angles with quadratic formula, and then real life problems here. Let's jam. Last time we went through here, we went through this slowly. That's right. I just wanted to show you, right? Multiple angles here. You got a 2 theta here. And we decided which way we want to do it. So we could either do the K value. I think we started doing K values. Is that right? There you go. So let's remind ourselves here. We want to get all the answers from 0 to 360. The only problem is we've got this little double angle right here. So what you have to eventually do is you have to divide by 2.
I do remember this.
If you divide by 2, you only get answers in quadrants 1 and 2. So we have to still get those other ones here. So what we do, we could solve it and just use K, and K will allow us to use the other ones, right? Because we'll get the other, just how many we need. You could also just think about going twice or 3 or 4 or 5 times around the unit circle, and that kind of gets crazy because then you have angles that we're not used to before. So example 2, we actually went back and we did it by the K value. So we did it, I think we did it like this, right? We did a 3 theta. So the question for us is, when is cotangent equal to 1? Well, cotangent is equal to 1 at the same place that tangent is equal to 1. And that is at pi over 4 and 5 pi over 4. Good there? Does that kind of bring back their memory here of Friday? So then we said to ourselves, that's cool. Okay, so that means theta is going to be equal to, or 3 theta is going to be equal to pi over 4 plus 2 pi k. And then the other one is that 5 pi over 4 plus 2 pi k. We divide by 3, and yes, we divide everything by 3. All denominators need to be divided by 3. And so by doing that, we don't ever get above 360 degrees as long as we go 0 is our first revolution, 1 is our second revolution, and 2 will be our third revolution. We stop there. We're good.
Wait, what's the 0, 1, 2?
Because we're trying to do 3 revolutions. If you're adding a pi, 2 pi to this guy already here, right? So if you're using 0, you already have your first revolution taken care of, right? So then if you use 1, that means you're going around it again, and then you're going down it a third time. So you're always, yeah, the question, yeah, the formula, if you want to do it by formula, it's always, whenever you have an n theta, your K values are always going to, the highest one you're going to get is n minus 1. So your max of your K value will be n minus 1. So if you do 3 theta, you use 2. If it was 5 theta, you'd use 4 as your last one, your K value. Okay, think we're ready for some? Let's go for it. So find all, interesting. Find all solutions cosine 2x cosine x plus sine 2x sine x equal to what?
Really like show us how to use it.
Oh, of course.
Okay.
So now the question is this. Can you, think Isabel got it right. You're going to go and you're going to have your formula sheet right in front of you. And you're going to see.
Okay.
What's the different formula of cosine?
With double angles inside.
So it's cosine of 2x minus x.
Mm-hmm.
Which is
Let's see.
x.
Oh, yeah.
So we have a,
It was just equals cosine.
Let's hang it
Mhm.
in.
That was 1 over 2, which was technically 2 over 2, which is at 45 degrees. So it's at pi over 4 and 3 pi. Wait, addition 0 to 1. Oh, so it's just pi over 4 and 3 pi over 4.
easy stuff.
Wait,
Absolutely.
no, it's cosine. So it's pi over 4 and 7 pi over 4. Tricky. That was mean.
We have a little formula that says this right here. And does that fit what's on top over there? Absolutely. So in this case, what we have is their A value is 2x, our B value is really x, and it has to be set equal to this right here, which is just, hey, this is not even a double multiple angle here. It's just using identity. Uh-huh. So you guys tell me, so real quick here, where does that happen? Totally agree there. And the answers are both of them. Absolutely. Don't need to go any revolutions because you don't have a multiple to the x. Just done. I'll think about it.
Well, you could have cosine of 2x and x, or even 4x and 3x, it doesn't matter as long as it's x. Anything like 1 over root 2.
Yeah, like 6x and 7x, but then it just subtracts down to just x, but then you get freaked out because you see a 7. And a 6. Like 8. 8 is a big number.
Oh wait, why would you? Come on, man.
Okay, add 1/2.
Add 1/2, okay.
So that's
Go
gonna
for
be
it.
at 60 degrees and at, let's see, it's gonna be pi over 3 and 5 pi over 3. No, yeah. Pi over 3 and 5 pi over 3. Then we have to do a ton of stuff, all that makes.
And then here, what I want you guys to notice is a pattern. That's what I want you guys to notice. So this guy cosine equal to 1/2, where?
Pi over 3, 5 pi.
Degree values,
60 degrees.
60 degrees, uh-huh.
Right. It's 6 pi over 3 to 2 pi, which reference angle is 60 degrees, so you just subtract 60 and subtract 5 over 3, it's 5 pi over 3.
Mhm. So I got
I
my
like to
2.
not guess and I just go with it.
Yes, always.
No,
According
because then if you're wrong.
to one.
So let's see if this is the case. You guys tell me if you guys agree. This is 8 theta is equal to 60 plus 360k. And the k that we're going to use, and I'm going to drop this down just a little bit here. This is going to be theta is equal to 300 plus 360k. And our k values are going to be between 0 to 7. Okay, but before we do that, let's divide by 8 just to get our numbers here. Can you guys, what is 60 divided by 8? Mhm. 7.5 degrees plus what is 360 divided by 8?
Wait, that's
Do it in your head, don't cheat your head.
All right, divide by 8 here, divide by 8 there, divide by 8 there. So theta 300 by 8.
37.5.
And I bet you this is 45 degrees.
I'm not dividing 300 by 8.
It's not that hard. 240.
All right. And if you want to do it by calculator,
That takes time. I do.
we should have 16 answers here, is that right? So notice what happens here is you just add 45 each time, right? So on the calculator, I think you guys know how to do this on the calculator. If you go like this, on first of all, I got 7.5. Yeah, plus 45, click enter. Plus 45 again, and then at that point, you just keep on going, yeah.
You should get 8 or 7 answers, right? You have 7.5.
That's nice. Notice I'm not entering it again.
So you just press enter.
Just keep on pressing enter. Notice what happens here on the calculator. So 1, 2, 3, 4, 5, 6, 52.5. 97.5. There's one actually says 10 theta. Yeah.
One different.
The other one is just 2, it bounces between 2 and 3 all the time. But just one way it has 10. And you can't put C calculator. 3187. Screenshot, love it. 232.5. 232.5. Uh-huh. Yep, 1. So 1, 1, 2, 3, 4, 5, 6, 7, 8. One more.
That makes sense, because it shouldn't get above, if it gets above 360.
Very good. Yeah. So notice if I click one more time, there it is. So you know I went above.
Oh, it's plus 45.
Very good. Very good in thinking there. Very good abstract thinking there. So 277, 322.5, 277.5, 277.5, and last one, 322.5. 322.5. Okay, that was 1 theta. Next one's gonna be 37.5. Okay, setup is the same on your calculator here, because this is why we do this problem, is to set up your calculator. So this is going to be clear. This is 37.5 plus 45, enter. So notice on this one, notice what happens here, right? Because what you're calculating. You're calculating 37.5 plus 45, right? So if you go plus another 45. And the easy way to do it is click it until you get to right before 360 degrees, right?
Yeah, this wasn't. Otherwise,
It should be the same.
it's
Yeah.
37.5, that's it.
Oh, so you could also just add 30. All your other.
Yeah, let's see.
I need it. Well, it's not 0.7, 2.5, it's 82.5.
I guess the difference, let's see, 300 minus 60 is 240, right? Divide by 8 is 30. So then, yeah, the difference between that angle going all the way to this angle is 30 degrees once you divide it by 8. So then there's a difference of 30 degrees technically between the two. So true. All right, let's see what we got on here. Just to make sure we got it. This one was 45, so 82.5. 127. $172.5, 217, 262, 207.5, and 352. You know that's going to be pretty much at the end here. We get 352.5.
The other one's 360.
Adding 45 degrees, I think we're at 190 something at this point. Yeah, once we have the 49. Yep. Cool. Okay.
The other one is closer.
Okay, we're good with that one. So, good calculator trick as we do those. Okay. Okay, so these guys are in the form of, first things first is just some kind of identity is going to help you along in the process. So keep your identity sheets out, super duper helpful. And this one. Yeah, exactly. What?
I like that.
This is irritating me. It's like Pythagorean theorem. I don't know.
Yeah, could be Pythagorean theorem, but before we get to, sorry, not Pythagorean theorem, quadratic formula.
That is what I meant.
Mhm. Before we get to the quadratic formula, we can just see maybe, possibly, maybe they factor. That's all.
Oh,
Is it- Wait, does it?
Let's
Add
see.
one and
Because you add one, because if it's -1, you couldn't, but if it's +1. Oh, that's it.
and then it's just use. Yeah, 2 sine plus 1. And then 2 sine, 3 theta plus 1 on the sine.
Ooh, okay, I think that's gonna work.
We still have to do all the answers.
+1 here and a +1 there.
Yeah.
Will I do it? Oh, my fault, my fault. It's a 3 cosine, it's 3 theta. There it is, +1, set equal to
So
0.
that's just gonna be -1 and -1.
Mhm.
Sine is -1 at 270 degrees, divided by 3 and 90 degrees. Sine is -1/2. $210 degrees and 230 degrees. And if I'm calling that, mentally not like calculated, if you're not don't do that.
Okay, so what K value we're using?
Up to 2.
Up to 2, so 0, 1, and 2. Okay, so this one, Abe, you said was 270 degrees, or radian measurements.
Oh, I guess it's being 3 pi degrees. No. Yeah, 3 pi.
3 pi over 2 plus 2 pi k.
Oh, they need the radian.
Then going over here, when is this -1/2?
Yes, that's going to be.
7 pi over 6.
Yeah. And then,
So 7 pi over 6 plus 2 pi k. And 3 theta is 11 pi over 6, just shy of 2 pi. 11 pi over 6 plus 2 pi k. Oof, okay, I got all 3 of those. Let me transfer these guys over.
oh, now we have to be.
That one over here. Let's scoot this one over here. Let's get this one a little bit more off the side here. Right there, there's our. Whoa.
What? I do that. That's good.
Okay. All right, let's go with the math here. Pre-algebra here now. Theta is equal to, what is it, 7 pi over 18? Is that what it is?
Oh, yeah.
Plus 2 pi over 3. Okay. Whoa. Okay. It is equal to 11 pi over 18 plus 2 pi k over 3. And, ooh, this one's nice.
That one's just. Pi over 2.
Pi over 2. Okay, all right. And so we're using k is equal to 0, 1, and 2. All right, as you guys finish up that, go ahead. And maybe even easier to do this right here. What do you guys say? Just to go with. Well, can I
Yeah, it's calculated as done.
multiply this by 6, multiply this by 6? Is that okay to make this 18 over 12? And this one over here, make this into, again, a 12 over 18. Makes it a lot easier. This one, 2 and 3, common denominator would be 6. So make this into a 3 pi over 6 and make this into a 4 pi over 6. That help. I think that's going to help quite a bit there. We'll put these two guys together. So theta 7 pi over 18 first, then add 12 more. We're good. So, ooh, that one does get reduced by 3, huh? 1 over 6. Add 12 more to this one, makes 33 pi over 18, which again gets reduced.
Oh, 21. 12%.
Oh, 19, okay, even better. I'm still learning how to add. This is 19 pi over 18. Nothing reduces there. Adding 12 to that. 31 pi. Okay, does not reduce there either. Okay, so that's even better. Okay, this one. Theta is going to be 11 pi over 18 is the first sign. Because we're doing 3 revolutions around. And it's going to pass 2 pi afterwards. So 23 pi over 31, 19 plus 12.
Just to keep doing it out. That's the 23 plus 35. That's going to be 7 pi. 7 pi. So 3 pi.
I'm alright.
7 pi.
7 pi or 6,
11 pi.
and then 12 pi or 6 would be 2 pi already, right? Because now we're too high. So there it is. Our answers again. This is with identities. Did we use an identity here? We did factoring here. That's what we did here. Okay.
That's a lot of answers.
That's not as many as the other one.
The other one was
You find it fun to have to calculate gradient.
It is mental math and homework. You should be able to do mental math.
I have not actually.
Everyone else in
All right, example 6. Here it is, degrees, back to degrees. Round the answers to nearest 10th, but it says use a calculator. So we're gonna kind of like run into some interesting things here. Let me move ahead just real quickly here because time, let me just see what time we have. Okay, yeah, this is second to last problem here. So, all right, let you guys try it first. Go for it here. Let's see.
You can't calculate. Or somebody else do the size like that?
Ooh, another problem. I have this. I have a sine squared and then I have a cosine.
Oh, that's cosine. I mean, yeah.
One's a sine squared, one's a
You
cosine.
can do that.
I read about
If they're both sine, I think you could factor
I
that.
don't think so, no.
Yeah.
Do it right now.
Come on.
Very huge. We're not bad.
I think.
You can't tell me.
I'm just gonna write that down once we can.
Okay, so do we have to do, we have the 2 sines, oh, it's 4 theta. Can we use the Pythagorean thing and make it a cosine?
You're gonna have to, yeah, because your linear form is a cosine, so you can't factor anything until your trig functions are the same.
That makes sense.
In this case, 2 times 1 minus cosine squared 4 theta.
Minus, oh.
So first things first, we got to get into the same trig
Divide
form.
through by -1. It's gonna be 2 cosine squared 4 theta minus 2 minus 1.
Mhm.
Subtract the 1, then divide through by -1. That plus that minus that.
That's all. Oh.
Yeah, was I right about that?
Plus 2.
Trying to do overlap.
Subtract 1 from both sides, gets you a +1. Divide through by -1, perfect. You can try to factor it.
You can't factor this either. Because if you have a 2 cosine, you can never, like a 2 cosine squared, if you factor it, you can never have a 2 cosine with 2 signs. There's always going to be a 1 there.
Absolutely.
Have to do this.
Quadratic formula, go.
Is there another way? No.
I think that is it. That's the only way to do that one. All right, give you guys a head start here. We've done, I think we've done 3 of these during this chapter. So think back to the chapters.
It's like the same answer every time we do it. Too. Like it's always the same. We have to 1 plus or minus 2, 3.
I do not even have the answers. All right, so I got cosine 4 theta is equal to that's A, that's B, that's C.
We just leave it at that. Yeah, we just did a.
Is it 12 inside here?
Yes.
2 root 3.
I had this -1, and then I went back and I checked it out.
It's -2 plus or minus 2. We need to divide it. 2.
Okay. So I have this.
If you get 2 answers for that, plus or minus.
Let me do it 4 times.
Well, no, cosine inverse. Because it's angle. Then divide that by 4.
Because we have this to deal with still, right? Cosine 4 theta is equal to -1 minus root 3 over 2.
It's terrible, I know.
All yours. Tell me what to do.
And did I actually do? I did those two, and then,
We're in radians or degrees here?
yeah, it's a good question.
Degrees.
Wait, if I did those two maths, do I need to do it right over?
Anybody tell me real quick, what is -1 plus root 3 over 2?
Good question. I was in radians when I did that math. It doesn't matter for that, right?
Yeah, doesn't matter for that.
It's 0.366.
0.366. I'll probably take it out because we're
And
trying to
this
get.
is 0 at that point, and then it goes to 2, so I just.
Gotcha. Okay, perfect.
And the other one is just -1.366.
Now we have to divide it by 4.
No, we don't.
All right, what do we do here? Would anybody see something interesting on the right-hand side?
Just have it plus. Or no, minus. Minus is.
It's a -1.366.
Alright, so it's like minus 1.72. What? If you just minus 1. It's the same decimal as it, but it's not just minus.
Ending.
Do you keep cosine inverse now?
Mhm.
Okay, well, if you do that, cosine of 30 equals -1.366, does not work.
Oh yeah, hold on. Yeah, this guy right here. Why does this not work right here?
So for what?
It's less than -1. Is that right?
Oh,
That guy goes away, and that's good. I like that. Now this one is, we're gonna figure out what the value gives us a reference angle of 0.366, right? So in your calculator, you're gonna punch in cosine inverse of 0.366, and what do we get? 62.53. Okay, so 62.6, usually nearest 10, I believe. Let me see. Round to nearest 10.
0.5.
0.5?
Yeah, 168.5.
What's after the 5? Oh, 3, okay. Okay, 68.
Sorry, 68.
No problem. Thank you. I do want to get the correct answer here, 68.5 degrees. Okay, that's the reference angle, is that right? So what's the other angle that we can get out of here?
Cosine, so that one.
Trying to get that one, huh? So what is that?
Oh, no, we're running around possible.
Around,
Wait, I do 60 minus 68.5. Is that?
Perfect. Okay, are we good there? This may or may not work out, but real quick, you notice that we're not at the end of the number. We're not got theta equals something, right?
No.
So Isabel?
You just divide this 2 by 4.
We could, yeah, but even more so.
When we
Yeah, I just wanted to
write
mention,
them out, as theta equals, no.
you could, yeah.
Well, 4 theta equals 68.5.
I'm more thinking about rounding off. When do we round off? We try to round off at the end, is that right? So even though I rounded in the beginning right here, it was actually what, 58.5, what, 3 or 2?
68.5 to 291.
Gotcha, okay. So I'm thinking if you divide by 4 off of that, that'll still work out. If you had to round up, so your numbers might be off just by a little bit. We're good by rounding off a little bit too early. And I will be okay with that, as long as you're sort of super close. Okay, I think we're good to go. We're going to do this. So 4 theta is equal to 68.5 degrees plus 360K. Is that right? 4 theta is 291.5 degrees plus 360K. So 68.5. Next. Oh, hold
No,
on.
divide it.
Divided, that's right, totally forgot to divide.
It's so long.
Indeed.
With the end of, even though we have six,
Is, I did it divided, I did 0.53, but it's 17.1325. So
17.1.
0.1 just fine, 90 degrees. 291.5 divided by 4.
I did 0.7. Seventy-two point eight seven five, so I did 0.9.
Mhm.
Wait, what's that? I didn't do that.
So,
Okay, so theta, okay, K values now, 0, 1, 2, and 3, are we good?
yeah.
And on the calculator here, go for it. 17.1 plus 90, enter, plus 90. So 1, 2, 3, 4, that's it. Is that right? 1, 2, 3, 4, 1. So 17.1 is the first one. 107.1 is the next one. 197.1. Thank you. 287. Okay. And I assume the next one I'm going to do is should pass 360, right? Passes 360. Absolutely. That's all done there. Jam over here. 7229. That's the first one. 72.9 plus 90 plus 90. Mm, 1, 2, 3, 4. Still 4 answers, right? On this side, 162.9.
So last one would be
252.9. 342. And done. Are we good there? Okay, 3 minutes left. Let's just check out this little problem here. Let's see. I'm not probably going to solve it yet here, but here it is. Oh, okay. So your author lives here in SLO. Did you guys know that? He teaches. Huh? I think as the author knows a little more about it, so therefore it's a little more like that. He lives in SLO. He teaches at Cuesta College. He's in his like 60s, so he wrote the textbook. And so a lot of these references, if you remember when we did angle measurements, you know how they did the SLO to Santa Maria and Napomo, is it? Remember that?
Yeah.
Right? We did that. So it is. Let's start it. We probably won't finish this. The average monthly attendance at, how do you guys say it? Nacimiento. Okay. Modeled by this function. X equals 1 is January. Use the model to determine the percentage of the year that the average attendance is 25,000. Wow. So in this case, what we would do, we would
very hard to calculate.
It goes 0 to 12, right? So that means months of the year, right? So somewhere in the process. So we're gonna set this equal to 25,000. Are we good there? And we're gonna subtract 19,450 from it, is that right? So we set this guy equal here.
That's just 5,500.
Subtract this one. That gets you 5,550, equal to all that. So you still have this little 18,550 cosine stuff here. Divide by that. Sorry, chicken scratch here, just to sort of know what we're doing. All right, if you get that, you should get down to a 0.2992. And so now you have this, you have cosine of pi over 6x minus 5 pi over 6. You guys talk to me here. What should we do here? Cosine inverse, is that right?
Oh, yeah.
Cosine inverse, and we'll finish off this problem on Wednesday. But you guys do have enough in order to do all the homework in 6.3 at this point. We good? Oh, yeah, sure. Which one? To this one?
So,
We'll finish off this one. We'll do it tomorrow. We'll do it Wednesday.
We'll do the full explanation.
Sure, absolutely.